Hello everyone, this video is going to cover sections 8.1 and also 8.5. Okay, so only 8.1 and 8.5. Both of them are applications of integrals, meaning you come up with an equation that requires solving an integral, and then you have to use one of the 4 or 5 techniques that you learn in in chapter 7 to solve the problem. Okay? Now here, like the name suggests, the arc length, technically all you have to do is measure the length of the curve. So for example, you have say one of the most basic functions, x squared. We already know how to find the area from, let's say, point A to point B. So we already know how to find the area of that using an integral. Now what this is actually asking is what will be the length from here to here. So this is what the arc length will be. Okay? And to find it, the length will be given by this integral. So the arc length from A to B is defined to be, for any function that is continuous, if the derivative is continuous, to be this. It will be the integral from A to B of 1 plus the derivative of the function square dx, and then just integrate. And like I say a few minutes ago, or a couple of minutes ago, the level of difficulty is going to depend what kind of integral you get in here. All right, so let's do this example. It says find the length of the arc of y equals to x squared, which is essentially this one, okay, between the point 0, 0 and 2, 4. So this is a fancy way to say that x is between 0 and 2, okay? So therefore, you graph this. Remember, x squared looks like this. If this is 2, this will be 4. And what we're trying to find is what is the length from here to here, from 0 to 2. Okay, so that's the arc length. All right, so this is what we have here. Y, or f of x. Remember, y and f of x are the same thing. So therefore, we have y is equals to f of x, which is equals to x squared. And obviously, y prime, or f prime, is equals to x. So that should be obvious. And therefore, the length is going to be the integral from 0 to 2 of 1 plus y prime square dx. And this will be the integral from 0 to 2 of 1 plus 4x squared dx. Now notice that here actually you don't have a lot of choices. The most convenient way to do this is going to be trig substitution. So therefore 2x has to be equals to tangent theta. That means that x equals to 1/2 tangent theta. That implies that the x is going to be 1/2 secant squared theta d theta. Therefore, you plug it in here. This will be the integral. We'll worry about the limits in a little bit. Of 1 plus tangent square theta, which we know is secant, times 1/2 secant square theta d theta. Notice that this is going to be 1/2 the integral. This one we already know is secant square, so you take the square root, that will give you secant, so it will be secant q theta d theta. Now we have evaluated this integral several times. Just check your notes. I'm just going to give you the answer. So here we have the 1/2. But the integral of this one is equals to 1/2 times secant theta plus tangent theta, and then plus ln of secant theta plus tangent theta. Again, you should definitely check your notes and check this. Now remember that the original question is in terms of x, so you need to change everything to x, and that's where you had to use the typical triangle that we used before for trig substitution. So if this is theta, then it has to be 2x, this has to be 1, because tangent of theta is 2x, so it should be 2x over 1. And then you use the Pythagorean theorem. Remember, this is 1 plus 2x squared, which is equals to 4x squared. So this simplifies to 1/4. Secant of theta will be this over this. Why? Because cosine is this over that. So this will be the square root of 1 plus 4x squared plus tangent theta, which is 2x, and then ln of secant theta, which we already say it was 1 plus 4x squared, and then tangent, which is 2x, and all of this goes from 0 to 2. Then just plug the limits of integration and simplify. So this will be like 1/4. This will be the square root of 2 times 2 is 4, times 4 is 16. So the square root of 17 plus 4, and then plus ln of the square root of 17 plus 4, okay, minus the whole thing evaluated at 0, which will be the square root of 1 plus 0 plus ln of 1, which is 0, and then just simplify. That's it. Like I said before, there is nothing new in terms of integration. The only thing new here is the formula. You just have to make sure you set it up correctly and then integrate, and that's it. Alright, you didn't get the last one. Here's another chance to redeem your sins. This problem actually looks more complicated than the previous one, but it's actually easier. You'll see right now. Alright, so this is what we have so far. So here, f of x is equals to ln of cosine x. Okay. Now, before we take the derivative, just recall, just in case you forgot, the derivative with respect to x of ln u of x equals to u prime of x over u of x. Okay, so this is something you need to remember for forever. So in this case, u of x is cosine, so this should be u prime. So the derivative of cosine, remember, is minus sine x, and then the derivative, and then cosine goes on the bottom because it's just itself. So notice that this is the same thing as minus tangent x. Therefore, f prime square is just equals to tangent x square. Okay. Alright, so now we have everything. We need to find the arc length. So the arc length from 0 to pi over 3, it will be 1 plus f prime square, which is tangent square dx. But again, also recall that 1 plus tangent square is equals to secant square. We have used this like 100 times right now. So therefore this is equals to the integral from 0 to pi over 3 of the square root of secant square x dx. There is no need to do any trig substitution here or anything else because they cancel each other out. This is just the integral from 0 to pi over 3 of secant x dx. But remember that the integral of ln x is the same thing as ln of secant plus tangent x, and this goes from 0 to pi over 3. So you put like the limits of integration, this will give you ln of secant of pi over 3 plus tangent of pi over 3 minus ln of secant of 0 plus tangent of 0. Now recall that secant of 0 is equals to 1, tangent of 0 is 0, and also recall that ln of 1 is equals to 0. So this whole thing is 0. So the answer is just ln of secant of pi over 3 plus tangent of pi over 3. And then you want to simplify that more, then you need to use the trig tables to figure out the values of this 2, secant of pi over 3 and tangent of pi over 3. Okay? But you can leave this as the exact solution. Okay. Okay, so let's try one more example. So here the function is y equals to the 2/3. So remember we need the derivative. Y prime is gonna be 2/3 x to the minus 1/3. And then you square this, y prime square is equals to 4/9, and then this is x to the negative 2/3, which you can write it as 4/9 times 1 over x to the 2/3. Alright, so therefore the arc length is going to be the integral from 0 to 1 of 1 plus y prime square, which is 4/9, 1 over x to the 2/3 dx. Now notice, and this is just to make the simplification easier, that 1 plus 4/9 times 1 over x to the 2/3 is the same thing as x to the 2/3 plus 4 divided by 9 x to the 2/3. Okay. And then if you take the square root on both sides, notice that at the top there's not much you can do, so just leave it alone. This will be x to the 2/3 plus 4. But in the bottom, notice that the square root of 9 is 3. And then the square root of x to the 2/3 is just equals to x to the 1/3. Why? Because x to the 2/3 times x times 1/2, which that's what it means to take the square root. The 2's cancel, so that will give you x to the 1/3. Okay. So therefore, this is the same thing as the integral from 0 to 1 of the square root of 4 plus x to the 2/3 divided by 3 x to the 1/3 dx. Alright, so we're gonna use the substitution. U is equals to 4 plus x to the 2/3. So this is substitution from calculus 1, basic substitution. So the u will be 0 plus 2/3 times x to the minus 1/3 dx, which notice is the same thing as 2 over 3x to the 1/3. And look at this part, this matches this already, so that's pretty good news. The only thing that is not there is the 2. So therefore this is going to be equals to 1/2 the integral of u to the 1/2. Remember that u to the 1/2 is the same thing as the square root of u of du. And the limits of integration are going to change from 0 to 1. If x is 0, this will be 0, so this will be 4. It will be x is equals to 1, 120 power is 1, plus 4 is 5. Or you can ignore the limits of integration right now, integrate, and then at the end change everything to x, and then integrate from 0 to 1. Either way is fine. So in this particular case, it will be 1/2 times the integral of u to the 1/2. It will be u to the 3/2 times 2/3, and we go from 4 to 5. So in this case, this is equals to 1/3 u to the 3/2 from 4 to 5, which is the following. It will be 1/3 times 5 to the 3/2, whatever that is from the calculator, minus 4 to the 3/2. This one is actually easy to compute because the square root of 4 is 2 and 2q is 8, so this will be 8. This one doesn't have a perfect square root, so you have to use the calculator. So in this case, it will be 1/3 times whatever 5 to the 3/2 is using the calculator, and it will be 8. And that's it. Okay, now we're gonna go to section 8.5, which is applications of integrals to probability. Integrals are very important in probability, especially for something that are called continuous random variables. Okay. So every continuous random variable has something that is called a density function, and the density function implies the following. If f of x is a density function, then the integral, wherever this is defined, has to equals to 1. That's what it means to be a density function. Then every continuous random variable also has something which is called the mean, or expected value, yeah, or the average. And the expected value, which is usually denoted by the letter mu, is equals to the integral, wherever this is defined, of x times f of x. Okay, so notice that you're going to use the density function multiplied by x, and that will give you the mean. And then we'll talk we'll talk in a little bit about something that is called the variance. So every random variable has these three things, and the variance is going to be the expected value of x squared, which is x squared f of x, minus the expected value of x, which is this. Okay, so notice how everything just involves integrals, and this one is usually denoted by sigma square. So this is the variance, and this will be the mean. Okay, so let's do a very easy example. Let's say that you have f of x is equals to k times x squared, and you go from 0 to 3. Okay, so the first question is which value of k, so part A, which value of k makes f of x a density function. Okay, like I told you, the only requirement to be a density function is that the integral is equals to 1. So therefore, this is what we have: the integral from 0 to 3. Why 0 to 3? Because that's what they give you, of kx squared dx has to equals to 1. So therefore, you integrate this will be k times x cubed over 3 from 0 to 3, which will give you k over 3, and then this will be 3q, which is 27 minus 0. So notice that this is the same thing as 9k. Okay, so therefore, if you want it to be a density function, well, the integral has to be 1, so that means that 9k has to equal to 1, which means that k has to be 1 over 9. Okay? So therefore, f of x equals to 1 over 9 x squared is a density function from 0 to 3. So in essence, you can change any integral into a density function. Okay? By the way, continuous random variables are usually denoted by capital X. So capital X denotes the random variable. So once you have a density function, that you can find probability. So if I ask you this, for example, what's the probability that X is greater than 1? Well, then this will be the integral from 1 to 3, because the maximum value that goes is 3 of the density function. So this will be 19x cubed over 3 from 1 to 3, or 1 over 27. If you plug in 3 in here, this will be 27, and then this will give you 1, so this will be 26 over 27. And that's the probability, which always has to be between 0 and 1. Okay? If I ask you what's the probability that x is between, let's say, 1/2 and 3/4, then this will be the integral from 1/2 to 3/4 of 19x squared dx. Notice that the integral is going to be the same. It will be 1 over 27 x cubed. But now this is going to go from 1/2 to 3/4. Or this will be 1 over 27. Remember, 3/4 is the same thing as 0.75. So this is 0.75 cubed minus 0.5 cubed. Then whatever that is. Okay? I mentioned that every random variable has a mean. So remember, the mean is the integral, in this case from 0 to 3, of x times the density function. Well, the density function in this case, remember, is 19x squared. So therefore, the average, or the expected value, or the mean, this will be 1/2 the integral from 0 to 3 of x cubed dx. So this will be 19 times x to the 4 over 4 from 0 to 3, or 1 over 36 times 4 cubed is 64, and then minus 0, so this will be 64 over 36. The mean doesn't have to be 1, it could be anything, it could even be negative, okay? But the probabilities always have to be positive in between 0 and 1. Now, you want to find the variance, so let's say this is part E. If you want to find the variance, which is denoted by sigma square, remember this is equals to the integral from 0 to 3 of x squared times f of x. By the way, this is 19. This is denoted, this is also called the expected value of x squared, and then minus mu squared, and we already found mu is this. So therefore, this will be the, if you multiply by x squared, this will be 19, the integral from 0 to 3 of x to the 4 minus 64 over 36 squared. So this will be 19 x to the 5th over 5 from 0 to 3 minus this. So in this case, this will be 1 over 45, and then it will be 3 to the 5th power minus 0, and all of this minus 64 over 36 squared, whatever this is, and this always has to be positive. Okay? So that's how you can check you're doing the right thing. So it has to be positive. Alright, so let's try one more or a couple more. Let's say that f of x is equals to this again, k e to the minus 4x, and here x goes from 0 to infinity. So this is going to give you a improper integral like the ones we did in 7.8. So the first part is for which value is this going to be a density function. So therefore the integral from 0 to infinity of e to the minus 4x dx has to be 1. So first this is equals to k. The integral of e to the minus 4x is minus 1/4 e to the minus 4x, and this goes from 0 to infinity. Remember that you are supposed to use limits to figure this out, but you don't have to do that anymore. It is always assumed that when you have infinity, this is on the limit. Remember that e to the minus 4x, the graph looks like this. So clearly this goes to 0 as x goes to infinity. So the first value will be 0, and then you plug in 0 in here. This will give you e to the minus 0, which is, okay, e to the minus 0, which is 1. So therefore this is equals to negative k over 4 times negative 1. So this is k over 4. So if you want this to be 1, well, clearly that implies that k has to be 4. Okay? So therefore, if I ask you what's the probability that x is more than 6, then this will be the integral from 6 to infinity of 4 e to the minus 4x, because now that's the density function. So then this will be 4, the integral e to the minus 4x, it will be minus 1/4 e to the minus 4x from 0 to, 6 to infinity, which is minus e to the minus 4x. So if you plug the limits of integration, over the infinity is going to give you 0, but then this will be minus e to the minus 24. So you need to use a calculator for them. So the answer is technically just e to the minus 24, which has to be positive. That's it. Now, you want to find the expected value. Remember, the expected value by definition is equal to the integral from 0 to infinity of x times the density function, which the density function is 4 e to the minus 4x dx. So you can take out the 4, so it will be the integral from 0 to infinity of x e to the minus 4x dx. And notice that here you're going to have to use integration by parts. So u will be x, so dv e to the minus 4x. So b is the x, and b is minus 1/4 e to the minus 4x. Therefore, we use integration by parts. You have the 4 outside, and then this will be ub, which will be minus x over 4 e to the minus 4x from 0 to infinity, and then minus b, which is 1/4 db, sorry, du, so this should be du, not db, du, which is the x from 0 to infinity. Notice here that if you plug in minus infinity, this will give you 0, and if you plug in 0, the whole thing will give you 0. So this will be gone. And notice that you have minus and minus is plus. So this is 4 times 1/4 the integral from 0 to infinity of e to the minus 4x dx. Okay. Now here you can just do the usual thing to integrate again, but there is an easier way. Notice that you can rewrite this as 1/4 the integral from 0 to infinity of 4 e to the minus 4x dx. We know this is a density function, so therefore the integral has to be equal to 1. So therefore the mean will be 1/4 times 1, or mu is equals to 1/4. That's it. Now, probably the most famous function or a density function in statistics or in probability is called the normal distribution, which the official name is actually Gaussian distribution, and sometimes it's just called the empirical rule or the bell-shaped curve. So if you draw a graph, this is how it looks. It goes from minus infinity to infinity. In the middle you have the mean, which remember is the expected value, and obviously all of this has to equal to 1. The density function is equals to 1 over 2 pi the square root times sigma, so sigma is not in the square root, and then e to the minus x minus mu square divided by 2 sigma square. Remember that mu is the mean or expected value, and sigma square is the variance, and sigma, by the way, is the standard deviation. Okay. So this is the most famous one. As you can see right now, to find integrals of this is very tricky. So that's why you have tables that already give you the solution, or you can use a calculator. But notice, and you should give it a try, this is a very good challenge problem. The mean, by definition, remember, is supposed to be the integral from minus infinity to infinity. By the way, here, this goes from minus infinity to infinity. So therefore, the domain is from minus infinity to infinity. So remember, by definition, the integral, the mean is going to be the integral of x times the density function, which in this case, well, the density is all of this beautiful thing right here. Now, you can do integration by parts to do this, and it takes a while. But once you do all of that, you will end up with exactly just mu. Okay? So if you are after the challenge, just try to integrate this using integration by parts, and you'll see that all of this will give you exactly this. You want to have to use this fact right here, that the integral of this is equals to 1. Or this is what I mean. The integral from minus infinity to infinity of 1 over 2 pi times sigma e to the minus x minus mu square over 2 sigma square has to equals to 1 because it's a density function. Okay? So that's the key to solving the problem, but it's still pretty long. All right, so that's it for 8.5.